So this lecture is the start of our study of chemistry. And what we want to sort of emphasize here is this idea of what is chemistry and why should I care about chemistry? And so as we think about these things, we can start with the definition. And one of the most common definitions of chemistry is this idea of chemistry is the study of the composition, structure, properties, and transformation of matter. But before we really delve into what that definition means, I just want to sort of emphasize some of the many ways where chemistry affects our lives, whether we know it or not. And so, a couple of the sort of ways we can think about is penicillins, antibiotics, drugs, pharmaceuticals, right? All of these are discovered or synthesized by chemists. So what's shown here is the molecule penicillin, and this was discovered by accident by Alexander Fleming after observing mold that was left out and growing in a petri dish. And so again, this phrase, it was discovered by accident. It was an observation that went to further study. And without this today, we would be in a much worse position without these antibiotics. We can also talk about the Haber-Bosch process. So the Haber-Bosch process is shown here, and the idea is it's formation of ammonia. NH3 is ammonia, and this one chemical reaction accounts for almost 5% of worldwide energy consumption. So I'll just say it again. So 5% of all the energy consumption in the entire planet goes to this one chemical reaction to produce ammonia. So why are we producing this much ammonia? For fertilizer. And you can see on our timeline here over time, the Haber-Bosch process is invented in the early 1900s. And soon after, we have a huge population boom. This is population of the planet in billions that comes after this process. And the reason for that is to be able to make so much fertilizer that allows us to grow more plants, grow more crops, and feed more people. We can also think about technology, things like LCDs, liquid crystal displays, the devices on your phones, on your iPads. These screens are all liquid crystals. And so this is development of molecules like the one shown that have very specific properties that allow us to have the screens that we use. That's not even just thinking about things like the batteries in these devices or the electronics in these devices, which are also heavily influenced by chemistry. And we can also think about things like plastics. Our world is touched by plastics everywhere, whether we want it to be or not. Things like polyethylene, polypropylene, polystyrene, all these things are large macromolecules, and these are all developed by chemists for their specific properties, and then we use every day. So this is just a few of the ways, and there's many more, where chemistry is influencing our world all around us. So as we go through the course, one of the sort of emphases we want to make, and it's one of the key ideas that I hope you stick with you, is the foundation of all science, not just chemistry, is based on observation and curiosity. This this idea that we have to observe something happening, and then we have to have the presence of mind to think about, hey, why did that happen? What's going on here? Right? A lot of the key discoveries are discovered by accident, and it took somebody to ask, huh, that's interesting. Why did that happen? And to go from there. So as we go through the course of our Ion Chem 111, some major themes that we're going to see, how does scientific measurement and uncertainty affect our understanding of the world around us? This is sort of this question of how do we know what we know, right? What is the precision of our measurement? Where are the holes in those measurements? What do we know, and how do we know it? We're going to talk about how does molecular and atomic structure affect chemical reactivity. One of the things that sort of we'll see again and again is the structure of an atom, the structure of a molecule, affects the properties and reactivity of that molecule or atom. So questions like, why does ice float? Why does sugar dissolve in water, but oil not? come down to the molecular structure of those things. And we're going to start to look at it and understand based on structure why this happens. What is an acid? Why does sodium explode if it touches with water, but sodium chloride dissolve? So what are the differences of these molecules? And then finally, energy. What is energy? Where does it come from? How can we harness different types of energy? Right, so these are the three major themes of Ion Chem 111, and we'll talk about these throughout the semester. So we'll finish this short lecture just coming back to this idea of we're starting chapter 1, which is about matter and energy. So let's put some definitions to things now. What is matter? And what is energy? And as we think about those things, matter we can define as anything in the universe that has mass, occupies space, anything with a physical presence. If you can touch it, taste it, or smell it, it's matter. Right? And we can think about energy is the ability to do work. And work is the energy required to move an object a given distance. And we'll talk more about what this energy means soon. So when we think about chemistry, we can come back to that starting definition and say chemistry is the study of the composition, structure, properties, and transformation of matter. So it's how anything in the world around us reacts, touches, how it feels, how it smells, right? This is the chemistry of the world around us. And that's what we're going to start to talk about in this course. Thank you.